Welcome back to Maths with Mrs. J. We've learned so far how to anti-differentiate or integrate polynomials. In our previous video, we learnt the special case where we have 1 over x. And in that case, we can't increase the index by 1 and divide by the new index. We'd be dividing by 0. We should know by now we can't do that. We learnt the fact that the integral of 1 over x with respect to x is natural log of x. I thought this would be a good point to pause for a moment and do some mixed examples, some of which will involve us trying to eliminate the fact that we've got a quotient or a product, some of which will be using natural log knowledge for our integral. And let's just have a go at some of these harder examples and see how we go. Don't get too bogged down in them. Don't get worried if you're struggling a little bit. Just take it step by step and you will find that you can do it perfectly fine. Let's have a look at our first example. Now, we should know by now that we can't integrate a quotient. We don't have a rule for that yet, all right? So a quotient as is we can't do. However, because we've just got one term in our denominator, we can in fact divide each of our terms in our numerator by that denominator. So let's do that. So we're going to get x to the 4th divided by x is x cubed, minus our 2x squared, plus our 3, plus 5 on x. Once we've got it in that format, it's relatively easy to do our integral. So we increase the index by 1 and divide by the new index. We increase the index by 1 and divide by the new index. Increase the index by 1 and divide by the new index. Here is where we need to be just a little bit careful and remember that we're going to get 5 times natural log of x plus, of course, our constant term. If you were to forget this rule, alarm bells should start to ring once you change that into a 5x to the negative 1, because if you increase that index by 1, you get to 0, and then you're going to be trying to divide by 0. You should know you can't do that, so hopefully that will trigger the memory about this business. All right, let's look at this next one. Here we should probably do some expansion of the numerator first. This is a perfect square, so we're going to get 3x all squared, which is 9x squared, plus 2 times 3x times 1, so plus 6x, plus 1 squared is 1. And that's all over our x cubed. Now, this is similar to the previous example. If you've just got one term in your denominator, it's perfectly valid to divide through each term in the numerator. Now, 9x squared on x cubed, I'm going to leave that as a 9 over x. 6x on x cubed, I'm going to write that as 6x to the negative 2. And we've got one lot of x to the negative 3, which is x to the negative 3. Now, we can go through the normal process. Just remember here we've got 9 times natural log of x. We're going to increase the index by 1, divide by the new index. Increase the index by 1, divide by the new index. And just tidying this up a little bit. So x to the negative 1 is the same as having x on the denominator. So we're going to get minus 6 on x. X to the negative 2 is the same as having, let me just get rid of that 2 there. It's the same as having our x squared in the denominator, but we've also got a 2 in the denominator. And there we go for that one. Let's have a look over the page here. Go back. At number 3. Now, clearly we can't do this one as it is. This is a full-on quotient. What are we going to do? Well, the order of the numerator is the same as the order of the denominator. So how about we do a division and see how we go? So this will bring back some memories for some of you. If we have our x plus 5 and we're dividing that by x plus 1. This is where you want to get leading term divided by leading term. X divided by x is 1. 1 times x is x. 1 times 1 is 1. Then we do our subtraction. 5 minus 1 is 4. So what that information has actually told us is that x plus 5 on x plus 1 is really 1 plus 4 on x plus 1. All right, so let's put this over here. So what we've actually got is 1 plus 4 over x plus 1. Now we can integrate. Integral of 1 is just x. This x plus 1 in the denominator, we should be thinking natural log. So we're going to get 4 times natural log of x plus 1 plus our c. The derivative of this x plus 1 is just 1. So when we divide by 1, you get the exact same thing. All right, let's have a look at the next one. Again, we're going to want to do a division here, a polynomial division. In this case, the order of the numerator is greater than the order of the denominator. That's fine. We can certainly do a division here. So x squared plus 1 divided by x plus 1. Again, we want to do leading term divided by leading term. Now, I'm actually inclined, let me just do this here, to put in our plus 0x. This will just ensure that we get our subtractions and everything correct. All right, x squared divided by x is x. X times x is x squared. X times 1 is 1x. Now, if I didn't have my 0x there, there's the potential that I could make a mistake at this stage. So we want to eliminate as many possible opportunities to make an error. 0x minus x is minus x, and we bring down our plus 1. Leading term divided by leading term is minus 1. Minus 1 times x is minus x. Minus 1 times plus 1 is minus 1. And when we do our subtraction, we get 1 minus negative 1, which is 2. So this over here is going to be the same as x minus 1 plus 2 over x plus 1. All right, polynomial division is very, very useful and in fact necessary when you're going to be integrating. All right, increase the index by 1 and divide by the new index. Increase the index by 1 and divide by the new index. This one, we've got next to the 1 in the bottom, haven't we? So if we've got the denominator is a linear function, we're going to just get 2 times natural log of that. The derivative of x plus 1 is just 1, so when we divide by that, we're all good anyway. All right, last one is a little bit more tricky. I've already set up our division here, and I've put in my 0x term. I find personally, even at my stage of maths that helps me to set it out like that. If you have your x term missing, then there is the potential that when you're doing a subtraction, you're going to make a mistake. Alrighty, so we're going to do a division. Leading term divided by leading term is x squared. X squared times x is x cubed. X squared times -4 is minus 4x squared. Do our subtraction. 2x squared minus -4x squared is 6x squared. Bring down, you can bring down the whole lot if you like. Now we're going to do leading term divided by leading term. 6x squared divided by x is 6x. 6x times -4 is minus 24x. Now they're going to go. 0 minus -24 is positive 24. Leading term divided by leading term. 24 times x is 24x. 24 times -4 is minus 96. When we do our subtraction, we get -90 minus -96 gives us positive 6. So over here, what we've really got is x squared plus 6x plus 24 plus our 6 over x minus 4. Now we can do our usual thing, increase the index by 1 and divide by the new index. Increase the index by 1 and divide by the new index. All right, I did that in one step. You can do it in 2 steps if you like. It was 6x squared on 2, gives you 3. Increase your index by 1 and divide by the new index, and then you've got a linear function in your denominator. So this will be 6 natural log x minus 4 plus c.